The following is a recording of our live event, which took place on February 20th, 2025. We hope you enjoy our presentation, which begins with a brief introduction of our presenters. Pam Morin has been the greenhouse manager at Johnny's since 2012, where she is responsible for the day-to-day care of research and breeding crops, managing over 40,000 square feet of greenhouse space. As part of her IPM program, Pam releases beneficial insects in the greenhouses and maintains their populations with banker plants. Pam was a vegetable market farmer before joining Johnny's and now has over 20 years' experience in the industry. Jon Alt has been the assistant farm manager for Johnny's since the 2020 season. Before that, Jon worked as a tractor mechanic at a farm machinery company and as the manager of a 1,000-member CSA farm in central Maine. He holds a certificate from UMass Amherst in sustainable farming and degrees in auto repair and medieval Greek history. In addition to his work at Johnny's, Jon co-owns Honeysuckle Way Flowers with his partner. Hello, Pam and Jon. I
Howdy.
have Pam off camera, but standing by, and we have Jon here. He's going to begin our presentation, so without further ado, I will step aside so we can get things started. Thanks, Jon.
Okay, thank you, Josh. Welcome everyone to Managing Pests with Beneficials in both the field and greenhouse. As was mentioned before, my name is Jon Alt, and here with me is my colleague, Pam Morin. We are with Johnny Selected Seeds and are excited to be presenting to you today. We do have a lot of ground to cover and not a lot of time, so let's get started. First, just a few quick words about us. The Johnny's Research Farm is located in central Maine, USDA Zone 5B, although in a previous era it was Zone 4. Things did change. Our growing strategy is predominantly organic, and several of our fields are fully certified. Unlike standard vegetable operations, we are a research farm, so our principal products are seeds, breeding genetics, and data. Because of this, the way we approach our field management is a little bit unique, and we actually plan on culturing some plant stresses, such as plant pests and diseases, so that we can fully evaluate our trial varieties. Our main operations are spread out across 10 locations, and there are 3 main enterprises on the farm, which are our breeding nurseries, our trialing plots, and the few acres we commit to yearly commercial organic seed production. We also run 19 greenhouses at 2 separate farms in a mixture of heated and unheated structures. Pam and I are on the leadership team, where she is the greenhouse manager and I am the assistant farm manager. Pam is the principal in charge of all matters pertaining to the greenhouse, and I have responsibilities in crew management, pest control, and seed production. For our topic today, we are going to tackle the question of how to manage pests sustainably by using certain principles of ecological farm design. This is a very broad topic, so we've decided to split it into 2 parts. The first part will be a discussion with me about how the farm employs farmscaping concepts in an open field settings, and then present a case study to illustrate how we dealt with a particular pest problem using those principles. While the second half will be a presentation on how to use biological controls in the greenhouse. I do want to be upfront that neither Pam nor myself are entomologists, but we still look forward to sharing our practical experience with you in using these tools of pest management. So with that out of the way, let's move to our first topic. We need to answer a few basic questions to better understand our terms and concepts. These can be considered the what, whys, and hows of our discussion. The goal of any ecological farm design system is to modify both your operations environment and practices to enhance the survivorship and performance of in-field beneficial organisms. This happens through both 1, providing the resources they need, and 2, through protecting them. Because beneficials are any organisms that can have a positive impact on the growing process. They are usually the natural enemies of select pests, but they can also include other local ecosystem service providers, such as pollinators or soil-dwelling insects like worms and springtails. Other life forms such as vertebrates, plants, bacteria, fungi, viruses, and nematodes can also be considered beneficials under certain circumstances. Growers are benefited by the fact that plants, their pests, and the enemies of those pests all co-evolve together in the environment. This natural antagonism between host and pest is what we can use when we try to exploit biocontrols. Sometimes biocontrols can be purchased and applied as commercially available biopesticides, but many of the more complex organisms are found in the farm are also local to your environment and ready to help your crops out, provided you provide them with a few critical resources and protect them from excessive pesticide sprays. And here is just a quick survey of some of the local beneficials that can be found in many parts of the eastern United States. These natural enemies are found across a range of insect taxonomy and can include beetles, bugs, flies, wasps, and spiders. Nematodes are also an important species to be considered in this lineup. These animals can be roughly divided then into two further sections, predators and parasitoids. Predators are typically large-sized generalist feeders where both immatures and adults may be predatory, while parasitoids are usually small-sized specialists that attack different life stages of their prey, such as eggs and larvae. Given their small size, parasitoids can be very hard to observe in the field without aggressive scouting, and you don't always realize that they're in the environment until they're not. And also, let's not forget, many animals like birds, bats, reptiles, frogs, etc., can also be considered beneficial under the right circumstances and can really do a number on pests. There are many potential allies in the environment that a grower can enlist in the fight against pests. So now that we've answered the question of what are beneficials, let's move to the question of why use them. At Johnny's, we use beneficials to make our operation more sustainable and our control methods more effective. There are very real benefits to the environment, as well as cost reductions connected to pursuing a more integrated approach. Employees also really appreciate knowing that you're thinking about their safety and considering their values when pondering what to do about pests. In fact, the first seed of expanding our biological control program was planted by a long-term employee of ours who asked the question of why are we spraying so much? We took the time to really think about that, which led to, frankly, some interesting results. Ultimately, we see ecological farm design as a component of integrative pest management, which is an ecosystem-based strategy that focuses on the prevention of pests or their damage through a combination of techniques. IPM planning has many aspects, including things such as monitoring, scouting, and actions based on pest count or damage thresholds. And this system privileges cultural, physical, mechanical, and biological controls over reactive chemical sprays. It's an approach that is not interested in the total eradication of pests, but rather works in complex with many other strategies to reduce overall pest counts to below damage thresholds. Complete destruction of a pest in an environment is not a desirable outcome, as that can result in a loss of that pest's natural enemies due to starvation. You should not seek a completely pest-free environment, nor will you get one, with IPM. Conceptually, we interpret the IPM-based prioritization towards biocontrol as though we are applying living insecticides, which can then further be defined as the use of natural enemies to reduce, prevent, or delay outbreaks of pests and plant diseases. As mentioned previously, these living insecticides can also include commercially available biopesticides, such as sprayable microbes. But for our purposes going forward, I'm just going to focus on the living macros, or biological control agents, that we try to attract and keep in the farm's field. These biocontrol agents, or BCAs, are the natural enemies that we want in the field fighting our target pests. Broadly speaking, there are two basic ways we utilize biological control agents at Johnny's. The first is either by physically releasing them, or the second is through attracting and supporting them through ecosystem design and conservation. Introducing beneficials usually involves the purchase and release of insectary-raised insects and is well suited to controlled environments such as the greenhouse, and I promise you'll hear about this from Pam shortly. Field releases, however, of purchased beneficials can also be done, but care must be taken to understand both your beneficials and target pest biologies for maximum impact. Poorly timed or improperly planned releases in the field can end up costing you money without much control. The other approach, and the one that we spend the most time on developing on the farm, is attracting local beneficials to your site through habitat modification by providing the food, shelter, and protection from broad spectrum sprays that these organisms need to grow, multiply, and generally be happy. This is what we mean when we talk about ecological farm design, and is what we also call farmscaping for short. So at the Johnny's Farm, we farmscape in three principal ways. The first is through habitat modification by growing plants that provide additional services to the natural enemies we want, such as extra pollen and nectar, alternative prey, and shelter. These plants help attract and retain our target beneficials, as well as grow their numbers, and serve as a refuge against any sprays that may need to be applied. Secondly, we try to make land management decisions that stress the pest by reducing pest habitat and employing cultural factors such as crop rotation or delayed planting where we can. And then finally, the last thing we do is trap cropping wherever possible. So trap cropping is where you plant crops that are more attractive to your pest than your cash crop, which then brings them towards the plants you want them in and away from those you don't. You can then restrict any sprays that you need to do to just the trap itself and keep the natural enemies you're trying to attract in the catch crop away from the sprays. Some specific varieties are especially well suited to trap cropping, and research such as the one on the slide here give you a little demonstration on what's available and how to make good decisions. Ultimately, however you decide to approach biocontrols, ecological farm design is worthwhile for its holistic benefits and relatively low bar of entry. Even just reducing the frequency of broad spectrum strays or moving towards a more narrow focused chemistry can have a huge impact, as most natural enemies and beneficials are especially vulnerable to insecticides. So now that we've talked about the concepts, I'm going to pivot towards a case study of farmscaping that I hope will better demonstrate this IPM in action. In 2023, we wanted to improve our pest control outcomes in the farm's cucurbit breeding nursery, which is an approximately 5-acre yearly productive plot consisting of hand-pollinated seed productions, test plots, and grow-outs meant to check seed genetic purity. This specific nursery is very important to Johnny's, and one where a seed crop failure can really set us back. To achieve this goal, we asked ourselves 4 questions, which were: what crops do we want to protect? What are the key pests attacking those crops? What natural enemies do we want to attract? And how do we attract them? So we have these known problems in the nursery, with large amount of cucumber beetle, squash bug, and green peach aphid mucking everything up, and then spreading bacterial wilt and viruses around because of it, which compromised our seed crops. For those of you who grow cucurbits in America, you should know very well what these pests would be very intimate to you. We tried to control these pests by spraying Pyganic to very mixed results and high input costs. We knew that we needed to do something different, so with the questions of both what crops we wanted to protect and protected from whom answered, we then moved on to consider the questions of what natural enemies we wanted to attract and how. This did take a lot of research. Fortunately for us as New England growers, we have a big long winter to do that, and we spent a lot of time reviewing all sorts of data and guidebooks for suggestions. And here on this slide is just a small example of all the publications that are out there, or some really of the publications that are out there for review. These resources were essential, and they encouraged us to enhance our local natural enemy population by reducing our chemical spray inputs and increasing the farm's biodiversity through habitat modification. So what we did is we first sowed a perimeter beneficial insectary crop to serve as a refuge and attractant to cucurbit pest natural enemies, and then planted a trap crop consisting of dark green zucchini and blue Hubbard squash within the edges of the field as defined by the insectary crop. We also added possible pest repellent plants between the trap and cash crop to break the field into different zones. In addition, we also relocated our most at-risk crop, the summer squash, away to our isolation cage farm and eliminated those plants' exposures to infield risks. We also sprayed organic pesticides in the trap crop only if they reached the threshold level and moved away from our practice of spraying reactively based on crop health. We then continued our practice of managing the field culture as follows, with black plastic beds spaced on 12-foot wide centers and 6 feet of hay mulch strip in between, and then row cover was applied to the crop at transplanting until flowering. Our insectary blend was designed to attract specific cucurbit pest natural enemies, and we tried to ratio our mix in such a way to prolong and overlap bloom times for maximum effect on beneficial support. Here in this slide is the list of the individual components of the mix that we made up that we've since called the bug blend. With this bug blend, our targets were as follows. You see spiders, soldier beetles, ground beetles, ladybug beetles, and then the two parasitoids, tachnid and squash bug egg parasitoid, Grione pessilvanicum. We wanted to attract these insects to our insectary crops, and we are very grateful to the research of Dr. Jamie Pinheiro in helping us determine what plants are attractive to what pests. And here in this slide is an example of his research. And so with that out of the way, let's get to the results. For visualization, here is what our Farmscape plan looked like in practice. Please note that this is not drawn to scale. We did this in 2 separate fields, one that was 4 acres in size and the other 2. From the standpoint of reduced chemical sprays, we saw some real success at first launch. Total pesticide treated area in the nursery went down 97% from 2021 to 2023, and chemical treatment costs went from a high of $700 per season down to $19. In addition, farm operations saw an overall decrease of 23% in distinct spray events across the whole farm. We also saw no further seed crop failures or pathogen contamination in the nursery, and since we only spot treated in the trap crop, we did not see any problems with phytotoxicity. Insect pressure was largely kept below action threshold. Additionally, we saw very large numbers of both targeted and not so targeted natural enemies, including an absolutely huge amount of hoverflies, lady beetles, and minute pirate bugs. Critically, near the end of the growing season, we also began to see signs of adult squash bug paradization by the flies we were targeting, which is something that I was especially happy to see given our objectives. So as for what did we learn, I could say the following. For starters, IPM planning can really make a difference, and it pays to understand your pest so that you can learn about what harms them and then apply the right kinds of pressure once you know how to deal with them. Privileging cultural, mechanical, and then biological controls often does result in both reduced input costs and enhanced control, although with biocontrols in particular, things can be quite complex. We recognize that we've only scratched the surface of what's possible, and we look forward to learning more, recognizing there are things that we can do continually to build improvements. In addition, it pays to consider your habitat modification timing and strategy as the natural enemies you may want to attack, or as the natural enemies you want may attack each other and be unable to disperse effectively into the center of the field from their protected locations. And what you plant for insectary crops could get in the way of your field prep. Also, natural enemies alone very likely cannot reduce pest numbers themselves, and they must be used within the larger IPM framework. Additionally, it pays to understand the characteristics of the beneficials you're targeting. Are they highly mobile? Do they hate to travel? What is their life cycle? How do they disperse? Figuring out these trends can help expand your thinking beyond annual methods and possibly get into more long-term perennial field plantings that might provide many additional types of ecological services beyond just pest antagonism. Finally, the importance of good records cannot be overstated. Without good data, you can't make good decisions. If you can, be intentional with your scouting and use good resources to help you with that. We use the UMass Amherst scouting sheets for our program and like them a lot. I've often heard the expression that the best fertilizer is the farmer's footsteps, and I do happen to agree with that. So with that out of the way, that's enough for me and applied infield IPM and farmscaping. I'm going now to pass the microphone over to my colleague Pam, who will share with you what she knows about the ecology of the greenhouse. So Pam, take her away.
Thanks, Jon. Hi, everybody. So some of the advantages of using biological controls in the greenhouses are we do not have to spray. We have much less chemical resistance. It's natural. There is no re-entry period, so it's better use of labor dollars. It's safer for the employees. It's great for marketing. Customers love seeing bios at work. I use both banker plants and indicator plants in the greenhouses at Johnny's. A banker plant example is barley grass that I infest with bird cherry oat aphids. Those aphids will act as a food source for the parasitic wasp that I purchase in case there is no green peach aphids active in the main crop, such as the house full of peppers. An indicator plant is a plant that is very attractive to a pest, such as thrips. You can monitor that plant and watch it for the presence of thrips. Jon talked about using the blue Hubbard squash as a trap plant. Marigolds are a great indicator plant to help you know if you have thrips in the tunnels. You can get them flowering ahead of your crop and the thrips will be drawn to them. While scouting, you can tap the flowers with white paper underneath it and get a good count of the present number of thrips. Once a plant gets a high amount of pests, you can use that plant as a banker plant for the thrips predator, such as the Aureus plant bug, or you can move that plant outdoors and treat it as an ornamental to draw in the natural enemies. Sweet alyssum is one of my major beneficial crops in the tunnels. It is a brassica family member cultivated as a flower rather than a vegetable. With small plantings made in and around our greenhouses here at Johnny's, its masses of tiny flowers are attractive to the natural predators, such as lady beetles, hoverflies, parasitic wasps, as well as green lacewings. Adult lacewings will feed on the alyssum pollen and nectar and then lay their eggs. On hatching, the lacewing larvae will help keep populations of aphids, mites, mealybugs, whiteflies, insects, and thrips in check. Because it prefers part shade, alyssum can be planted beneath vegetable crops, such as onions and other alliums, to help control pests such as onion thrips. It has a very long bloom time and is very easy to grow. I place them at the end of rows and tuck them into the corners of the greenhouses in unused space. They're a wonderful source of pollen, and I often release my bios directly onto them. This plant is also very good at attracting natural predators from the fields into the tunnels. Purple flash ornamental pepper is a very high flower producer and a great pollen source for the Aureus. I will have one of these plants in containers for each of the active greenhouses here at Johnny's and release the Aureus directly onto the plants. A bush bean is also a great indicator plant for spider mites inside a tunnel. The bean will attract spider mites away from the tomatoes, and you can be made aware that they are present in the structure well before the numbers reach a threshold that you are not comfortable with. I usually use 3 or 4 plants inside the tomato houses. After I scout and I find the presence of spider mites, I can then use those spider mites as a food source for the spider mite predator. And so at that point, the beans become a banker plant. And then I will purchase the Persimilus mites and release them onto the bean plants. I start grass banker plants every couple of weeks beginning in April here in Maine, so I always have a fresh source to work with. I put the plants into a screen protector and infest them with the oat aphids and allow them to multiply so I have a larger number of aphids to feed the parasitic wasps. I then take a couple of the plants out and put them into a larger container with some fresh seeds sprinkled around the grass and place them in the greenhouse. It's helpful to keep them on drip irrigation so they don't get forgotten about. Then I reseed a couple of new containers and add them to the screen tent. If I'm able to keep this cycle going, I have new banker plants stocked for most of the season. These are the screen tents that I use to grow the barley banker plants to protect the bird cherry oat aphids from getting parasitized from predators that are already in the greenhouse. I do say use caution if the grass gets too tall and touches the screen. The beneficial wasps can sting right through the netting. This photo is of bird cherry oat aphids growing on barley grass as a banker plant. You want the populations on the grass to be quite high, so there is a good food source for the wasps after you release them. Be sure to monitor your banker plants so you can see if mummies begin to show up. Oftentimes you can see the Aphidius colmani hovering around the plants. And this is a photo of the parasitized aphid mummies. You can see the exit holes where a new wasp has emerged. When I see this on banker plants, it's a great sign that the system is working. Live lacewings come in a cup like this and makes release very easy. Keep the cups inside the greenhouse and there will be eggs sticking. There will already be eggs sticking to the insides of the cup. You can see those in the picture, the little yellow dots. You will find them under the leaves, and I've even seen them under greenhouse benching. Lacewing larvae work great for placing on hot spots. I like to buy them in the hex cell trays as they will cannibalize each other in transit. And then we have praying mantis. I purchased the Uthicas in the early spring and I put them in all the tunnels. There was a pretty good survival rate, and we find full-grown adults in the fall when we are tearing out the summer crops. They are fun to have around, and the greenhouse and farm crew really enjoy finding them. At Johnny's, we construct pollination cages to provide an environment to grow seed and exclude natural pollinators to keep the seed pure. This photo is from a couple of years ago when we constructed pollination cages in our main trial field. The pipes fit together, and then we add screen covers to the tops of the frames. We plant the crops in the spring and introduce pollinators, such as bees and blue bottle flies, to ensure pollination. Early in the crop cycle, we plant beneficial plants that provide a pollen source until the other plants are in flower and can adequately sustain the insects with pollen. And that includes sweet alyssum, dill, cilantro, and nasturtium. We also build small structures we call flysolations because we release flies to pollinate crops, such as chard and brassicas, inside the greenhouses, so that we may have several types of plants inside the covered structures, producing seed for research all at the same time. The larger tunnels get starter hives. We have specially built shelters for the hives inside the cages to protect them from direct sun and rain. And we make sure to plant extra flowers for pollen to ensure the bees are kept happy. After the breeder selects what they want to keep, we build these tents around the groupings of plants and release flies into each chamber for pollination. The seed is then allowed to mature, and we hand harvest it late in the fall. These are the flies that we use. They're blue bottle flies. They work in cooler temperatures, and they don't seem to mind a smaller area compared to bumblebees.
They don't sing.
This is another net example of what we use to keep plants isolated when we use flies as pollinators, and we call them mini ghosts because that's what they look like. And on some closing, it's good to keep really good records. Know historically when your pests usually show up. Scout regularly and identify your pests properly so you know what beneficials to buy. Buy from a reputable of your shipment. There are many good companies out there, and they're all very helpful and have great resources created to make it easier for you. And we are including a link to a document called Commercially Available Biological Control Agents for Greenhouse Insect and Pest Mites. And that's a document that I go to often. It has photos for ID, general use in the comment sections that will give you some hints and tricks on how to use them. And it even lists the optimal temperatures in which these beneficials are active at. That's it. Thanks.
Great, thank you, Jon and Pam. Hi, everyone. My name's Liv. I'm going to moderate our Q&A session now, so we'll jump right in. Thank you, everyone, for sending in. We got a ton of really great questions. I think I'm going to start. I'm going to try to make most of these in the order of the presentation. We may end up jumping around a little, but I'm going to start with a few I think that are targeted towards your slides, Jon.
Okay.
So maybe we could start out with, there were some folks wondering how you decide where to place your trap crop, like how far from your cash crop, and that sort of thing.
It's a good question. So what we have done in our system is that we do perimeter trap cropping. So we have two beds on the edges of basically we have trap crops that go around all the edges of the field. So depending on your bed orientation, we'll have two crops running the length of the beds, typically in blue Hubbard because they vine all over the place and kind of get along unruly. But then at the heads and feet of each bed, so the tops and bottom of each row, we'll plant the dark green zucchini. So that's why we were able and why we wanted to move in the direction of diversifying the trap cropping so that it could account for different growth habits in the plant. There is a lot of research about the proper and most effective spacing. I don't have a great answer for that. I can only speak to what we do, and it has generally good effectiveness, especially on squash bug, because if you do the perimeter planting, the squash bugs, they overwinter in the field margins typically, and so they walk into the field. And so if they're walking into the field and they spot the buffet item they're most hungry for, they stop, and that's where I've seen them really shine. I'm certain the more you have, the better. I've seen some research suggesting a ratio of 2 cash crop beds to every 1 trap crop bed. We don't do that. We can't do that. We're limited by space and constraints like most people are. But I would say that if you wanted to try it, prioritizing your decision making around the perimeter, making it so that it's an unbroken system around your field is a good start. Does that answer your question?
I think it does. Yeah, thank you. Okay, so then we also had a couple questions about the bug blend. A lot of folks are interested on what's in there, and maybe you could speak to what will be shared afterwards. But then also kind of, if it's annuals and perennials, how do you think about terminating it if you need to? And do you need to rotate it as you would, for example, like different cover crops?
Yeah, so we are treating there's a lot in that mix, and I believe there are some that are considered perennials, but we just treat it as an annual mix, where we have so basically it's reset every year at planting, or field prep, I should say. The thing that we're not perfect on, and where we're learning more lessons and letting experience sort of build like our program is, we don't know. We're still working on like the proper timing of events, because the first year we did it, I believe we sowed the insectary mix after we had laid the beds, the plastic, but prior to us shredding the mulch and doing the transplanting. So basically, wherever there were tire tracks, the insectary mix got eliminated, which over a course of a very large field can result in a pretty significant loss of the insectary crop. So there are the field prep considerations you got to ponder, and there's the different components of the mix that you can ponder. One of the things I mentioned at the end of my presentation was thinking about how to incorporate perennials, like such as creating a beetle bank, which is something that I would like to see us do in the future. We haven't gotten there yet, but that's something where you would create a mounded system of grasses, more or less, that you would leave untouched, more or less unmanaged, unplowed all year, and there'd be these strips that could break up your field. So there is a way for you to incorporate this perennial farmscaping design, but for our purposes, and until we sort of make sure they fit right for our needs, we're treating this mix really as an annual production.
Yeah, Great.
And
Thank
I
you.
guess about as far as the rotational aspect is concerned, the the big part of this is buckwheat. That's the thing that ends up being predominant, especially it grows. I mean, everything in there was selected for quick maturation, quick growth, and then the insectary services. There are limited diseases that affect insectary, buckwheat in particular. Like there's like buckwheat's rust, I think, but it only impacts that crop in specific, particularly. So I think there are limited concerns about rotation personally, or if there are some, they don't outweigh the other ecological benefits of having the mix.
Okay, great. Um, we also had a couple questions. Do you use living mulch? Do you try to incorporate your insectary plants as a living mulch between rows of crops?
Mhm. So we, so our current culture of doing spreading hay mulch, we are trying to crack the code on making that living mulch or using a crimping system on a winter rye. I would say that we're trying to bias our decision making on the insectary mixes towards insect services, like trying like the floral services with the nectar and the fact that it's a refuge away from the crop if we're spraying. So there's a little bit of decision making that is has some opportunity cost. So like if, for example, I want to plant a mix that maybe has a benefit for mulching on weed control, I can't really do that with like buckwheat or some of the things that are really beneficial to insects. So it's kind of a give and take. Are there possible scenarios or solutions out there? Absolutely, but it does require, I think, some experience and experimentation with the mixed content, the planting time, the crop culture, the equipment you have. There are some cover crops that don't really incorporate all that easily. So we're trying to use the skip lanes. We call them skip lanes, the space between the plastic, for weed control primarily weed control. Now, curiously, some of the things we're trying to attract, especially the carabid beetles and some of these ground beetles, they eat a ton of weed seed. So where I think there might be some future is in looking into these beetle bank systems I described earlier, which would be a permanent system. So
That's great. Thank you. All right, one more question for you, Jon, and then I'll give you a break and move on over to Pam. There are a couple of people who wanted to ask, could you repeat the name of the field guides that you use? I think maybe they were UMass Amherst, and
yeah,
maybe describe a little bit of what's in them.
yeah. So I dropped the I know we dropped the link in the resource for the web resource, but we use for our IPM planning a lot. We principally use the publications coming out of UMass Amherst. They're fantastic. They have in their IPM laboratory sheets, scouting sheets that we just pulled them directly from the web and use them for our own purposes, and that's what they're designed for. We like them because it's Massachusetts, it's pretty close to Maine, they generally have the same problems we do, and they're just a quality institution. So we use those scouting resources, and then we also use what's called the New England Vegetable Growers Handbook. It comes out every 2 years, and it's like sort of the byproduct or the result of a lot of land grant universities from Maine down to Cornell and New York that get together every year or every 2 years and like basically spell out what they think the best practices are on disease and pest control. That resource guide in particular is heavily slanted towards conventional production, but it does still have good information on organics too. So I would say if you're looking for two quality resources, the UMass scouting guides, and then if you're in New England Vegetable Growers Handbook, you really can't do any better than that. I consider that my Bible. I use it all the time. They also put out a greenhouse version as well that I know Pam uses.
Yep.
They're fantastic.
Yeah. Great. Okay, Pam, we have some questions about banker plants. Maybe could you start out with just sort of like how to start a banker plant and maybe any of the challenges you've encountered doing
Okay.
that?
So the first thing that I would do is obtain some barley seed. I happen to like barley better. It tends to last a little bit longer. That's my favorite one. So I will, the nets that I have, the tents that I showed on my slide, that size will hold about 4 6-inch square pots. So I take 4 pots, put soil in them, add my barley seed, and then I go ahead and put them into the netting, zip it up, and let it germinate. I give it about a week, and then I go ahead and order a banker plant. I get those from IPM Labs in New York, and you'll essentially get a package in the mail that is a bunch of little barley grass starts, and it's already infested with the bird cherry oat aphids, and it's grown in rock wool. So all you have to do is like pull it apart, and then I take a little section and I put it right into each of the containers that are inside the net. So that's how I infest the grass that I've already started. And then I will leave that in the net for probably, I'd say, at least 2 weeks. And it's important to keep the net closed up. You don't want anything to get in there. And you have to water it really carefully. So this is a challenge I know a lot of people have, is when they water their banker plants, they use their water breaker wand in the greenhouse and they wash their aphids off. So you're reducing the number of aphids because you're drowning them basically. So it's really good if you can bottom water them, if you can put some type of water reservoir underneath the pots and bottom water, and that disturbs your aphids much less that way. So once you see a high number of aphids, and it can be quite a lot, then you know they're ready to use. And then I will take 3 of them out at a time and put them right out into the greenhouse. Sometimes I add more seed around them, so it'll continue to germinate new grass, because as the aphids multiply, the grass really gets desiccated from the aphids. So having new seed always germinating kind of refreshes that plant. But as soon as I remove 3 and put it out into the greenhouses, I start 3 more and I put it right back into that same net. So essentially I have like the mother stock plant that's always continuing, and I'm using the oldest ones first.
That's great. And how long would you say that system lasts? Like, do you just keep reseeding a few plants every week or 2, or?
Yep. So if I take 3 out to disperse them for use, I'll start 3 more. And usually I can go until July or August. It all depends on how well you care for them. Sometimes they forget to get watered, and they'll die. Then you need new ones. Sometimes people will leave the zipper part of the tent open by mistake, and then the parasitic wasps that I release in the greenhouses get into that tent, and they parasitize all my aphids that I'm growing for food source. So I get more wasps that way, but then I also have to buy more aphids. So you have to really take care of it and watch it and make sure. If the grass gets too tall and the blades of the grass touch the netting, the wasps that are already in the greenhouse can land on top of the tent and they'll go ahead and sting right through. And then you'll have parasitized mummies inside your tent. So you have to start over then usually too. But I usually do 2 rounds. If everything goes well, I do 2 rounds. One in the spring and then one in late summer. The late summer one takes me into probably late fall, because we do overwintered crops. So that gives me a little bit of supplies for that.
Great, thank you. Some folks are interested in where you can purchase beneficials, and there was also a question about where to purchase the actual tent that you're using.
Oh, yeah. So the tent, you can actually go right on Amazon and you can search, I think they're called butterfly tents. They sell them for like children to raise butterflies in. But you can get them in all different sizes. I really like the bigger ones, but sometimes they're hard to get. You can use search term like banker plant tents, and I think it'll also come up a bunch of suppliers as well. I get a lot of my beneficial insects primarily through Griffin Greenhouse Supply, because I also buy many things from them. Arborco Organics is really good. Arbico sells smaller quantities of insects that are sometimes more preferable for home gardeners that don't want to buy, a $500 container of parasitic wasp. They sell smaller amounts. I get my Banker plant from IPM Labs, and also Evergreen Grower Supply is also very good.
Great.
Those ones
Thank
I've had luck with, yeah.
Yeah, that's great. And then so once you receive your beneficials, is there a way that you can tell that, they're viable and ready to go?
Yeah, so I have kind of like a magnifier that I can plug into my laptop. It's called a Dino Light, and it will help me to see the beneficial insects better. It magnifies them and has a little light on it. You can actually take pictures and save it on your laptop. Or you could use just a regular jeweler's lens, the loops. Those are really good too. So I will sometimes dump a sample out onto a piece of white paper, and against the white paper, you can really kind of like see the mites crawling around. They are hard to see sometimes. You have to like put them on the paper, wait a minute. Sometimes you just like lightly blow on them and it sort of will get them crawling around so you can see them to make sure that they're alive. Like the live lace wings, those are alive when you get them and you can see, they're in the can. But the mites are the ones that you really need the lenses to look at to make sure you can see movement.
Can I add one thing, Pam?
Yeah.
So Pam mentioned the white paper for like the really small insects. We use that white paper to check for a really high class native beneficial called minute plant bug or minute pirate bug or aureus. Like
Yep.
so, they love marigolds and they love to hang out in like really like fluffy flowers. So if you take that piece of paper and shake it, usually you can start finding them. So that's one way you can tell that your system is attracting and good antagonists.
We hit the flower. We
Mhm.
kind of like punch the flower, and then all the bugs will fall out onto the paper.
Oh, great. We had a couple questions like, how do you know when the right time is to release your beneficials? I'm guessing that's also a question about like, how do you know when the right time is to order them so that you're getting them when you're going to need them?
Yeah, a lot of it is for me, it's history. Like I know in, the beginning of the spring when I'm doing the seedlings, we're gonna have thrips show up. So I start putting the predatory mites out on the seedlings of the tray stage preventatively, just to make sure I'm covered. Um, a lot of it is based on history when pests show up and
Mhm.
scouting records. Um, what do you think, John? Is that
Yeah, I mean that's where the records are going to be really
Yeah.
important. Some pests are like their biology or their life cycle is tagged based on what's called growing degree days, which in the open field setting can be helpful to sort of evaluating timing. But this question is partially why it's very difficult to do big releases of insectary reared bugs in the field. Because there's just a lot of things at work. The records really is going to be one of your better guidelines, and then also if that's what the bankers are there for though too. So you can fudge your timing a little bit in a
Right.
controlled environment because they're not going to starve. And then there are some insects like the aureus I just mentioned. They want to have their prey, but they'll live off of pollen in the meantime if they need to. There are some beneficials that are omnivorous like that and could do well, without the pest, but there are others who are obligate who need it completely, and if they don't have it, they will just die and disappear.
Yeah.
So it is kind of part of it's on selection too. So if you can select for a species that maybe like are very forgiving, you know what I mean, on like your timing, that could be a strategy to consider as well. The only other thing I'll add too is that even if like there are insects that can eat pollen or nectar and the meat of their prey, having the insectary resources around is still going to be beneficial because it could make them more virile. It can give them more increased fecundity. They can lay eggs more. They can require less energy to do the things they need to do to sort of just live their day. So if they only have 100 calories to spend in their life and they're spending a lot of it under stress, that's going to reduce their effectiveness overall. But it's a good question. Timing's a good question.
Yeah.
All right, great, thanks. Okay, let's see. So we have a grower who's wondering about reflective mulch. If you're using reflective mulch to try to, reduce your pest populations, is that going to negatively affect your beneficials also?
Most likely. I mean, it would totally depend. Like the reflective mulches are good with aphids, and that could be part of like your IPM strategy is to factor that as like one of your cultural controls. But usually if it's affecting, insects, like they find things based on sight, but mostly smell and some other things. And so if you confuse them or make things difficult for them to find, that can also impact their natural enemies too. So there is a bit of a balance. Pam, I'm looking at you because I know you recall. Mm-hmm. I used to try to do sticky traps in a small isolation, like a controlled isolation that of peppers, and I encountered this realization that these sticky traps, which are yellow, that are meant to attract aphid flyers to the sticky, also attracted the Ophidius colmani wasp. So I was capturing as many predators as I was the aphid. So that's where like kind of knowing the selecting for the insect and knowing it's important, and that's where the dispersal also is really important too, because there are the parasitic wasps are super tiny, and generally the smaller the insect, the harder it is for them to fly unless they can, or travel far distances unless they can grab the winds. Like the bigger, like my favorite beneficial locally is flying soldier bug, which looks very similar to just a invasive brown stink bug, but they're really strong flyers and they'll fly miles, but there are lots of beneficials that aren't going to fly hardly at all. And so that's another thing you need to think of when you're trying to decide if you're in field and you want to disperse things, like where do I need to place these insects? Because you consider that too, don't you, Pam? Like if you're using highly mobile big insects, you just kind of set them in the greenhouse and walk away, right?
Yeah.
But the mites, you have to pretty much, you kind of sprinkle
them.
I
sprinkle. Yeah. They come in a shaker can. Looks like you could do it on a salt shaker.
Yeah.
And just sprinkle them on the seedlings that way. Some growers use leaf blowers.
Yeah, I've seen that. And like, don't they put it in like yeast?
Yeah.
Yeah, to help as a dispersal agent.
Yep.
Yes, there's all these different ways. It's pretty amazing. Like there's so many insects out there, and like I really wanted to stress like there's a lot of native parasitic wasps that are just amazing, but you almost will never see them because they're so tiny.
Very small.
Like and they only host on like one species or two. It's pretty cool, including, unfortunately, other beneficials. Like there's a lot of parasitoids of ladybugs, and there are things called hyperparasitoids, which are parasitoids of the parasitoids. Yeah. So that's another funny thing. It's amazing. Nature's so cool.
That's great. Thank you. Let's see. Okay, so we had a couple questions about some of the plants, Pam, you talked about in your slides. The sweet alyssum, can you use any like cultivated sweet alyssum variety, or does it have to be anything specific?
Yeah. I like the white, and I like the varieties that stay compact. They don't spread as much, and they bloom for a longer period of time because they do get tired and they go to seed. So the compact ones seem to last longer for me.
Johnny sells that, right?
Yeah, Johnny sells it. Yeah.
And then the purple, I think it was an ornamental pepper. Is that true?
Pepper.
Yeah.
Yeah.
Okay. Yep. They just wanted a repeat on the variety name to make sure they got it.
We don't sell that one.
Yeah, we do not sell that one, unfortunately, but I do purchase those seeds because it's very, very highly abundant flowers.
Aureus loves it, right?
Yeah, I use it for a food source to Aureus. Yeah. So when I get that plant bug for a beneficial, if there's nothing in the greenhouse for them to eat, they'll live off the pollen and be happy, which is what a lot of the banker plants is. You're creating this like restaurant for your insect. So if there's no other insect in the crop, they'll be happy and stay in your house until the insects eventually come, because they always do, right?
Yeah.
So, yeah, you just have to like create a little hotel for them.
That's great. All right. Well, we're closing in on 5 o'clock. I think we'll make this next question the last one for the evening, and it's just about IPM soil preparation techniques. So I think you did speak to this a little bit, but I wasn't sure if you wanted to talk a little bit more about sort of best practices and sort of getting the soil right where it needs to be for your bug blend and other strategies.
With regard to like sowing the insectary crop, or more just general like how to pests and stuff. I'm a little.
Yeah, I think the question was about sort of like soil preparation in terms of nutrients and like I know you had mentioned, crop rotations prior and that sort of thing.
I'll answer that maybe in a slightly different way. I think number one, like going back to it's everything should be seen within like what are you doing? Do you have an IPM plan? Like I think IPM planning is absolutely critical, and everything else comes from that. And one of the easiest and most effective and most important things, and right on the list top of IPM plan, is crop rotation. So crop rotations can, I've mentioned in my slideshow, create a hostile environment to the pest. It disrupts their life cycle. It takes them away from their food. It makes it harder for them to get reinfested. Like, so I go back to the squash bug. I think it's the cutest insect, but I really hate it. It has wings, but it walks. It like prefers to walk. It like, so if you rotate, I mean, it's a lot for a small grower, but if you rotate your stuff a mile away, of course, excuse me, a quarter mile away from the previous planting, it can't find it. And so, and then even if it does show up, it's half starved, and it takes 4 weeks later to get going, which is going to reduce the overall load. So, and then there are plenty of insects that pupate in the soil. So if you turn them up and expose them to the ground, above for the birds to eat, there's things like that. There are things like that I would say for pest control that could be effective. As far as like questions on fertility, that's a little bit of beyond the scope of this, and I actually don't have as much experience with that and wouldn't feel as confident with my answers. But generally, breaking the pest life cycle is a good thing to consider when you're doing crop rotation, driving it away from its food source, and then providing alternate opportunities for that insect to be attacked is great. Some pests, they overwinter as larvae, some overwinter as adults, some overwinter as pupa. So, like depending on the life cycle when you're targeting in particular, if you learn how they overwinter, that could be a place where you could learn where their weakness is and exploit it through some other means. Like even like, if an insect is an adult and goes into a field margin, you could mow that margin potentially, and that could reduce the likelihood of that insect to survive the winter. That's just an example of the importance, I think learning the pest, identifying the pest, learning their life cycle, and then applying pressure where it's most vulnerable.
Well, great. Thank you. I'm going to pass it to Joshua for some closing remarks.
Thank you, Liv. Thank you, Jon and Pam, for sharing your expertise with us today. It's a lot to unpack. There's a lot of resources that have been referenced. We're going to make all of those available to you folks. And thank you for the great questions, everyone. We're sorry we couldn't get to everyone's questions with the time that we had, but if you still have questions regarding these topics discussed today, please reach out to us. We can take your questions via live chat, email, or phone. Our team will be happy to help you. And then, as mentioned in some of the chat posts I put up earlier on, a recording of today's presentation, the slide deck, and the additional resources, they'll all be available at johnnyseeds.com Saturday morning, February 22nd. You're going to receive an email in just a minute with a link to where those resources will be Saturday morning, so please hold on to that email. And finally, special thanks to all of you who joined us today. We hope you found this presentation informative and inspirational. We hope it'll help you with planning for your year ahead. So again, thank you. Until next time, best wishes from all of us, the employee owners at Johnny's, and have a good evening.
Bye.